Hi everyone, and welcome to the next video in the WLED bedside lamp. In this one we're going to be looking at the circuit and then building on the PCB. The circuit I'm going to show you is actually the second version of it. This PCB was built from the first version, which I discovered actually there were some enhancements that I really needed to make in order to actually make this a bit more, user-friendly is probably the wrong word, but it makes it more universal and it adds some features to it in order to basically use the additional buffers that are still on the chip. So looking at the circuit, not a lot's changed from the nanoleaf replica circuit. So the central part here where we've got the D1 mini, pretty much the same. So you've got the D1 mini, you've got the push switch, there's the output going to the buffer, and then a relay output. That's probably the biggest change here, which we'll come on to in just a second. The buffer then outputs from the, turn that on, there we go, don't know why it does that. So the buffer outputs to a connector, which then obviously goes over to the LEDs. Then probably the biggest thing here, and this is where some of the changes happen between the first board and the second one, is in this section here. So you've got 3 spare buffers within the chip. This enables them to be used if it's desired to, so it enables them to be used relatively easily. So what you've got on here, there are 2 jumpers, 2, I can't even count. There are 3 jumpers, 1 for each buffer. Then there's another set of buffer jumpers over this side. So these are just solder jumpers, so they can be closed quite easily. Then there are some connectors which enable connection to the enable pin, the data input and the output. So these central jumpers, they basically just connect the data input down to ground. So if they're not going to be used, that can be soldered over. The other ones, these have got 3 positions. You can connect either the enable pin constantly high, so that way it will stay off. You can be connected to low or ground, which will mean that it stays on constantly. And then it can be left floating, which then means that the connector will determine whether it's enabled or not. So yeah, if the whole point of that was just basically to open up those spare ones so that if you needed to do anything else, so say for example you wanted another output, you wanted to be able to connect another string of LEDs to this, then you can jumper over from the pin on the D1 into the connector here, set the solder jumpers however they need to be, and then that's it, you've got access to it there. So looking at the rest of the circuit, not an awful lot more to say. Power in with a protection diode, but the biggest change here is with the relay. Now again, in the previous nanoleaf one, we used the relay output to just use it as an indicator so that some LEDs would come on to say that the unit is actually on and trying to output. So even if the brightness is set very low and you can't see the LEDs, you at least can see the indicator LED and know that it's on. Now the actual purpose of that output was to switch an actual relay. So what that enables you to do is actually turn off the LED strip entirely, because with these strips, even when they're actually off, as in there's no light coming out of them, each of the controller chips in here is still using some power. So the advantage here is this can actually then sever the power to this, so that way it's not using any power at all while these are actually off, or at least while the controller has told it to be off. That is just a very simple circuit, pretty normal. So you've got a transistor switch with the, I'm using a BC547, literally just because I've got absolutely bucket loads of these. So it was just a convenient one that I had to hand. Really important with relays for anyone who's never really used anything with an inductive load. You've got the back EMF. So this diode here, basically when the magnetic field collapses, it can induce a current onto this, and if you don't have that diode to basically allow it to stay within the coil, then it will try and go through the transistor and basically just blow it. So that is really important that that is on there if you're using the relay itself. But that's really the circuit. There's not an awful lot to say about this one. Like I say, most of it's been said in the previous ones, but just really to cover most of it. Quick thing on here, so just at the bottom here you can see there's some additional symbols. Those are just placeholders. So down on here we've got the placeholders for the holes that need to be drilled and some extra ones just for the logos and things that are on there. So let's now look at the PCB and start building that. So we get one here. As always, end up with 4 more than I actually need, but there we are. I will say if anyone wants one, drop us a line and we'll see what we can do. So in terms of building this, there are some other changes that have happened from this one to the second version. Now, one of the biggest ones, if you take the relay and actually pop it in, it actually fouls on the first connector for the LEDs. Now that's a really important one because that one there, J1, actually is the only one that carries the data output. The other two I put in place just in case you've got a longer strip of these and you want to get some 5 volt and inject it a bit further up the string. So it gives you access to the 5 volt without having to worry about trying to solder on the back of anything or have extra cables coming out. So, coming out of the input connector. So that's the idea of those ones there. But unfortunately, like I say, I didn't take into account, I made an assumption, and that's always a bad idea, that the footprint on here was a largely universal size, and this one is ever so slightly longer that way. So it does foul on that. So one of the things I'm not sure how I'm going to deal with that quite yet. I might actually solder that connector with these boards, actually from the underside, so I can still connect into it. But ultimately it's not an ideal set of circumstances. So the actual next version of this, they'll be pushed over slightly so that way you've got far easier access to it. Now, like any soldering project, we're going to start with the smallest going up to the largest. Now in this instance, the smallest on here is actually the buffer IC. Now what you might notice here is the buffer IC, which these legs, you might find the legs splay out a little bit when they're supplied. So what I do on here is I basically get hold of this and then just roll it onto a flat surface, so I can just gently push the legs in a bit so they're more straight onto it. So the idea here is that we'll pop that. Ooh, I think I've gone too far there now. So that's taking a bit of finagling to get that in there, but that's in there now. So the idea is that this is actually going to be stacked. So you've got that there, and then the controller will actually effectively sit on top of it. And there should be just enough height for all of this to go in, assuming I can keep that in the position it's meant to go in. So that way it basically can stack on top, allowing the just a slightly more useful space, or allowing there to be less space effectively on the thing. So let's get this all soldered up now. Connector now. Still not sure whether to do pop them in there and then just hope I can basically ram this down on top of it and I can get a good connection. I'm also seeing another slight thing with this one in that I need to move that relay over a bit just so you've got easier access to the reset pin or reset button on the side. But okay, let's try that way from the top first, and then we'll change if we need to. Okay, so here's a little circuit. Now I'm not going to put the switch on here. I have designed this so that the switch can be removed and taken off board. It can't obviously be removed from here, but I've labelled it so you can see which side you need to put any switch on that you want to use. So that is available on there. And the final design that I've got for this will actually take advantage of taking that off of the board, just so that, mainly so that the button can be more centralised. So just cosmetically it looks a little bit nicer. So that's that all done. So the next thing really is to power it up and see if we are actually working. Okay, so what I've managed to do here, such a bodge job, is my little 3D printed adapter actually, so I can convert a standard barrel jack into, was actually designed originally was designed for a breadboard, but I've connected up a couple of cables so that I can connect onto there. That goes into here. So if we plug this in, immediately what should happen, I hope, is that the relay should engage, because this is programmed to come on with a white LED to begin with. So hopefully, fingers crossed. There we go. I don't know whether that comes through on the microphone, but that clicked into place. So let's unplug. Let us plug in our LEDs. And hopefully, let's try that again. There we go, perfect. So that's that one there. Let's make sure our wires are not, or solder is not going to go across and short anything out. So that's the circuit done. The final video in this will be designing and making the 3D enclosure for this to go in, 3D printed enclosure for this to go into. That will be designed so that it goes onto the underside of the lamp, so you can just press a button, this comes on, press a button, it goes off, and that's it. But yeah, it seems to be working. Let us just very carefully pretend that the button's just been pressed. So hopefully this should then power down the LEDs, and then we should hear the click of the relay. Oop, I don't. Perfect. And then if we go the other way, immediately click of that, and then they come back up. Perfect. So, yep, that's it for this video. Thank you for watching, and I'll see you in the next one.